Okay, so good morning, everyone. So this will be our first discussion right after the overview and orientations of the course, no? The business analytics or fundamentals in business analytics. Okay, so everyone who runs a business would tell you that making decision is the most important task in the role. So business managers are always faced with questions on what to sell, how much to sell, to whom, through what mode, and the manager or entrepreneur has to know how much it would need to make his or her product and how to cut down on expenses, how to market the product customers, and when the business can be expanded. Decisions do not just come about on their own. So they are a product of analysis based on the information available to the decision maker. Business managers have always gathered information to base their decisions on. But with the development of computers which can store and process large amounts of data, business analytics began to offer more possibilities for decision makers. So in this module, we will be able to learn more about the role of business analytics, big data, and business intelligence.
Good day, everyone. This is Eric Capistrano from UP Diliman, and I will be sharing with you some of the fundamentals of big data and business analytics. This course will be divided into three aspects. First, we will be dealing with the introductory part, followed by some fundamentals on database and data management, and thirdly, we'll be focusing on business issues and business challenges for big data. So what is business analytics? So first of all, we'll be looking at the business analytics, which will be comprising of several different tools and techniques that are crucial for business analytics. So first off, we'll be looking at what is business intelligence. It's all about combining aspects of reporting, data explanation, and ad hoc queries. And what is also analytics? Analytics is also a part wherein we are going into different modes of statistics, analysis, and interpretation of all of this data. So for moving on, the funny thing about big data is that there are several different definitions from different companies. We'll be looking at some of them. From SAS, this includes large volumes of structured and unstructured data that inundates a business on a day-to-day basis. For IBM, however, they're saying that it is generated everywhere around us at all times, arriving from multiple sources and alarming velocity, volume, and variety. However, Gartner will be looking at high volume, high velocity, and high variety of information assets that demand cost-effective and innovative methods for us to deliver good quality data. So moving on, so we'll also be looking at what is big data as opposed to research. Research also mentioned a lot of things about big data, and that would include it being in terabytes, petabytes, or even exabytes of data. Take note, this world now generates 2.5 quintillion bytes of data which are produced daily. That's a huge amount of data that we are looking at right now. And all of these are now processed into reliable, predictive, and recommendation functions based on a combination of processes, statistics, and descriptive and predictive data that are used to produce good results. Furthermore, we are now combining both proprietary customer data and public data to produce more accurate information for us to use. Moving on. So what defines big data? There are 4 aspects that we can see here right now. First of which is volume. Volume is all about how huge the data sets are. Variety, which includes how many sorts of different pieces of data we gathered together, from social media data, government data, financial data, banking data, all sorts of transactions, all combined together to make one or more profiles for your customers. Third is velocity. Velocity is the speed of data. Every day we see hundreds and thousands of Twitter, Facebook, stock market data, and all sorts of different information coming around. Uber data, for example, weather data, all of this can be combined together to make good results. And lastly, veracity. This is one of the biggest challenges of big data. Veracity means that there's a lot of uncertainty, meaning with all of these different pieces of data coming together, but the problem is we don't know what to do with them. So there's subject to a lot of different interpretations based on several different factors such as society, culture, and even your own gut feeling. Big data can also be defined as the following. You can group these big data into different categories, different sorts of quantity, quality, and many other things. So the point here is that even until now, we don't have really a very good definition of what big data is and what it can do. So this is why it is important for us to study it further. So what it can do. Some of the previous research would be mentioning something about the combination of data. What you see right now is just a sample. So let's say I go on a trip. I go to a trip, I take a vacation, and I use my credit card to make purchases for hotel, airlines, and whatever tickets for entrances to theme parks and whatever. So what happens is that the bank captures this data, and based on that data of all of what I paid for, it now processes all of those transactions and makes a profile of me. In other words, the bank is starting to judge me. Now, how can they verify that this is all about me? They can stalk my social media. Once I go to the country of destination, I post pictures, I post my check-ins, I post my statuses, I tweet, I do Instagram, and if all of this is public, then the bank can verify that this is indeed me. And doing so, that it can confirm that, oh, this person, I'm the one who really went to this place, bought this stuff, and they can do a better profiling of me. Now, what is the end result? They can make better recommendations the next time I use my credit card for me to travel or to even shop. So that's how it basically works. You get public data, you get proprietary data, and then you get personal data from different sources, and then you combine them together, and that's what big data is all about. Some of the investments in big data that some of the large companies have been providing are as follows. So productivity has said to be up by 5 to 6%, and business growth has grown to at least 10%, which has created at least 4.4 million jobs created over the last few years. Big data has also driven systems effects on growth. So you can see some of the big increases and improvements in value in manufacturing and retail with such huge amounts, and we're talking about in the billions. And also on the other side, for credit card firms, for example, they were also able to save money because they were all now protected from frauds and credit risks due to this big data analytics. So, and furthermore, the business data market value now is at $25 billion, and it will be up more to $53.4 billion by 2017. And the economic contribution of big data has been calculated also to breach $15 trillion by 2030. Lastly, the software market for big data is now valued at $16 billion, growing at an annual compounded rate of 8% per year, and investments are expected to also increase to $76 billion by 2020. So, lastly, who are these providers of big data? We've seen such a huge numbers of this, and we're also seeing a lot of big things that are happening. So there's actually an entire supply chain, an entire value chain of these big data services that are happening. So you can see here now that there are different layers with different providers and different companies which are now producing all of these services and products and software and hardware for us to produce big data. So this map tells you at least an impression of what is happening now when it comes to this big data analytics. So to close out the session for now, we're looking at just a little bit of what big data can do from us. So in the next few sessions, we will be looking at some of the more fundamental aspects of how we can combine both the data management services that is required and the business practices that are also required for us to use big data properly. So at the end of it all, we are hoping that we can understand how all of this works so that we can better apply and manage all of these things that big data can do for us.
Okay, so in the era of the knowledge economy, getting the right information to decision makers at the right time is critical to their business success. And one such attempt includes the growing use of business analytics. Business analytics is one of the most talked about topics in the field of business and information technology. So as expected, business analytics is becoming one of the most sought after courses in the academy. Business analytics, or BA, of course, goes through your mind when you hear the word business analytics. Now, business analytics is the art of assembling the data gathered through business intelligence in such a way that it can be analyzed by people. It is comprised of the tools with which people can disseminate the data that's been collected to produce meaningful conclusions. Business analytics is the use of data, information technology, statistical analysis, quantitative methods, and mathematical or computer-based models to help managers gain improved insights about business operations and make better fact-based decisions. So, business analytics is comprised of solutions used to build analysis models, no? And simulation to create scenarios under realities and predict future states, including data mining, predictive analytics, applied analytics, and statistics. Business analytics is the study of data through statistical and operations analysis. So the formation of predictive models, application of the optimizations techniques, and the communication of these results to customer, business partners, and college executives. Business analytics refers to a broad use of various quantitative techniques such as statistics, data mining, optimization tools, and simulation supported by the query and reporting mechanism to assist decision makers in making more informed decisions within a closed loop framework, seeking continuous process, improving through monitoring and learning. Okay, so business intelligence now, let's look at what business intelligence is. Business intelligence as the process of collecting information from all sources to make data-driven decisions in an organization. Because business intelligence as the process of combining aspects of reporting, monitoring, alerting, dashboards, scoreboards, or scorecards rather, and ad hoc query data exploration. Now, the origin of business analytics from ancient times, people have had this need to predict the future. They have used crude methods like stones and sticks to project how much crops they were going to harvest or how much they were going to yield. So in this discussion, we shall trace the development of business analytics from the ancient to the modern time. So, based on the given presentation earlier, it discusses about big data and business analytics. A while ago, we have defined already the business analytics and business intelligence. This time, let us learn another concept related to business analytics, which is the big data. So, what is big data? SAS defines big data as a term that describes the large volume of structured and unstructured data which can be analyzed for insights needed for better decisions in strategic business moves. IBM, on the other hand, refers to it as the data sets whose size or type is beyond the ability of traditional relational databases to capture, manage, and process the data with low latency. So what is the difference? Business analytics is said to focus on financial and operational analytics of the business, while big data involve machine automation to analyze data. The importance of big data is not on how much data you have, but what you do with those data. And there are actually 4 aspects that define big data, which are volume, variety, velocity, and veracity. So, volume is about how huge the data sets are. Variety includes how many pieces of data we gather together from social media data, government data, financial data, banking data, all sorts of transactions all combined together to make one or more profiles for your customers. Velocity is the speed of the data. And veracity means that there is a lot of uncertainty, meaning there is all of these different data coming together, but the problem is we don't know what to do with them. So, over the past few years, you must have heard the term big data, which is defined in different ways. So, big data describe the large volume of data in an structured and unstructured manner. So, the big data belongs to a different organizations, and each organization uses such data for different purposes. So, a large amount of data is not critical. The rather critical part is how organizations are using this data. Big data is a data set that is huge and complex so that traditional data processing applications are inadequate to deal with them. So there are challenges to managing such a huge volume of data such as capture, store, data analysis, data transfer, data sharing, and others because big data follows the 3V models as high volume, high velocity, and high variety. The importance of big data is not about how much volume of data is present. Rather, it is focused on what you do with that data. A long list of big data service providers which are now available in the market can be, of course, found in the internet. No? So we have the top big data companies right now. We have iTech Art, InData Labs, ScienceSoft, Right Data, Integrate.io, OxAgile, IBM, HP Enterprise, Teradata, Oracle, SAP or SAP, EMC, Amazon, Microsoft, Google, of course, VMware, Splunk, Alteryx, and Cogito. So That is an example of a software, no? Or the top big data companies. So this time, we may proceed to Module 2. So information in its raw form is not much useful for business decision making. It has to be collected, analyzed, and present in a way that it is useful for decision making. In this module, we shall discuss the framework that allows us to turn this information into valuable data. So we shall discuss how data becomes business value and explain the basic concepts on data analysis, framework, data extraction, data warehousing, and data analytics. So this will be the framework for business analytics. So the process of turning raw data into business action is the framework for business analytics. Actually, there are 3 steps in turning data into analytics, which are data extraction, data warehousing, and the extract, transform, or load processes, or ETL. Data extraction, no, this is the first step in turning data into analytics. So there are at least 3 sources of data, which are the source systems, raw transactions, and from documents in forms. Data warehousing, this is where the data is cleaned, curated, organized, and ready for analysis. And the ETL, or extract, transform, or load processes, this is the process of moving data from source system to data warehouse to an analytical tool. Okay, so there are types of analytics. And now that we have collected the right data and processed them into usable form, we need to find at what level we are going to dig deep into the data to get the fact-based insight. And we need to find out so we can come up with better business decisions. There are 3 types of analytics that can help businesses make the most out of the big data that they have and find the solutions to problems that they have. And the 3 types of analytics are descriptive, predictive, and prescriptive. Okay? So descriptive, predictive, and prescriptive. So descriptive analytics, this is the data that is used to benchmark or to profile. Predictive analytics, this is used to determine relationship between 2 different types of data and making predictions about future data. And prescriptive analytics, this is used to create recommendation through simulations and optimizations model. Okay. I just want to discuss it one by one. No? What does descriptive analytics entail? So, descriptive analytics is the evaluation of past data in order to better comprehend company trends. Using a variety of historical data to make comparison is denoted by descriptive analytics. So, the majority of frequently reported financial metrics are the results, no, of descriptive analytics, such as year-over-year pricing adjustment, month-over-month sales growth, the number of users, and the total revenue per subscriber. All of these metrics indicate what has transpired in a firm during a specified time frame. So, descriptive analytics parses raw data and draws insights that are relevant and easily understood by managers, investors, and other stakeholders. A report detailing $1 million in sales may appear amazing, but it lacks context. So if this number reflects a 20% reduction month over month, it is cause for alarm. If the rise is 40% year over year, it shows that something is working well with the sales plan. So to have a complete understanding of the company's sale performance, it is necessary to consider the broader context, including its growth objectives. So, descriptive analytics employs a comprehensive set of data to provide an accurate depiction of what has occurred in a firm and how it differs from other comparable time periods. And these performance indicators can be used to identify areas of strength and weakness, hence informing management plans. Data collection for descriptive analytics is accomplished mostly through data aggregation and data mining. Before data can be analyzed, it must be obtained and processed into information that is manageable. The information can then be utilized by management to understand the status of the firm. Descriptive analytics is one of the most fundamental forms of business intelligence. Despite the fact that descriptive analytics might be industry specifics, such as the seasonal variation in shipping completion times, analytics utilize widely accepted measurements prevalent in the financial sector. Return on invested capital is a descriptive metric formed by converting three data points such as net income, dividends, and total capital into a simple percentage that can be used to compare the performance of one company to another. In general, the larger and more intricate a business is, the more descriptive analytics it will employ to evaluate its success. In particular considerations, descriptive analytics gives essential data in an approachable style. Descriptive analytics will always be required. Newer domains of analytics such as predictive and prescriptive analytics are receiving increased focus. This sort of analytics utilize descriptive analytics and incorporate extra data from a variety of sources to anticipate probable outcomes in the near future. And this predictive analytics go beyond information provision to aid in decision making. And these forms of analytics can also propose action that optimize positive outcomes and reduce unfavorable ones. Rapid facts, descriptive analytics give information regarding what happened, regarding a company's activities, while whole diagnostic analytics provide information regarding why did it happen, and predictive analytics provide information regarding what could happen in the future. However, civilization is not yet at the positions where all large enterprises will be led by kind and perceptive computers. So, the majority of decisions made in offices and boardrooms around the world are still based on the same descriptive analytics used 10, 20, and 30 years ago, such as whether sales were up or down compared to last month, whether the product is reaching the market on time, and whether the company has sufficient supply based on last month's number.
Welcome to the lesson. Today we're going to talk about descriptive analytics. In today's lesson, we're going to tackle what are the techniques in descriptive analytics. And learning the techniques, what are the various types of tools that you can use to perform descriptive analytics. First, what is descriptive analytics? Descriptive analysis concerns itself with presenting data as it is. Techniques for descriptive analysis aid the analyst in summarizing data for better insight. You're not yet predicting anything, you're not yet taking action. What you just want to see is how do things look like today. The most common approaches to descriptive analysis include cross-tabulation, hypothesis and inference, and data visualization, and we'll be going through each of them in a minute. The first methodology in descriptive analysis is cross-tabulation. Cross-tabulation is just essentially getting granular bits of data and transforming and aggregating it into a form that makes it easier to understand. For example, in this table, we have transactions. And you want to understand, okay, is there a relationship between where a transaction takes place, the amount of the transaction, and what kind of payment method people use? And looking at a table like this, it's not really very easy to figure that out. But if we perform a little bit of cross-tabulation and say, look at, okay, what is the average amount paid on credit for each of these 4 regions, and what is the average amount paid using PayPal, and then get a percentage distribution of each, it's now relatively easy to see that, okay, those who made their payments coming from the East region seem to prefer credit, while those who make their payments from the North and the South regions prefer another payment method. So that's the power of cross-tabulation. And various types of analytics actually build on top of cross-tabulation. So this is the most basic methodology that every analyst should understand. The next methodology is hypothesis and inference. So now that you've transformed data, aggregated it, you want to start drawing some early conclusions. You're not making any predictions yet. You just want to understand, okay, if the data looks like this, what are the types of inferences that I could get from it? So as an example, you may have a table like this, which you've aggregated already. So these are from the accounting world. You're looking at various accounting indicators. And again, looking at a tabulation like this, it's really hard to understand how and when all of these indicators move with relation to each other. One type of hypothesis and inference method is called correlation. So by performing a correlation test and looking at, okay, does my net profit move in conjunction with my current ratio? And then you visualize it using a heat map. Then it's now more intuitive. I can see that all of my profit measures move together and all of my liquidity measures move against each other. And the colors are giving the analyst clues which factors move together and which factors don't. So this is an example of an inference test using correlation. There are many types of inference tests. Another test is maybe you want to compare the behavior of 2 populations. So maybe you have 2 groups of people. These are 2 different sets, let's say, of students. And these are their ages. And you want to understand, do these 2 groups belong to the same population, or maybe they're slightly different? One type of inference test is called the t-test, which compares the average value of 2 populations. So I won't get into too much detail, but this is an example of a 2-sample t-test. And you can visualize this using a histogram. So now I see group 1 are the blue bars and group 2 are the orange bars. And I can see that, okay, now that I've grouped these 2 populations by their ages, it seems like the first group tends to be quite younger compared to the second group if I'm now visualizing it using a bar chart like this. So this is again an example of transforming data in a descriptive way and getting some insights out of it. Which leads us to data visualization. So once you've already done your cross-tabulation, once you've done your inference test, the best way to show your insight is to visualize it. Because not everyone likes looking at rows and columns on a table. So some common examples of data visualizations are charts. So for example, one of the most popular charts is called the time series chart. So you're basically just looking at how a value changes over time. And you see if there's any seasonality in this pattern. That's the most popular. Another type of chart is called a stacked area chart. So you're not only looking at changes in time, you're looking at composition, how it changes. So let's pretend this chart was a chart of the revenue coming to your company. And you can see that yellow area is now the biggest part of that stacked area chart. That now tells you that, okay, now most of our business is coming from that yellow segment. Well, that orange segment has sort of disappeared. So maybe that's a line of business that no longer is yielding any profit. So you can see how visualizing it in a graph gives you an intuitive feel of where these values are, rather than just looking at points on a table. We saw a heat map earlier. A heat map is actually just looking at a table, but with colors. But by adding a colors, you get a sense of relative weight. So now you know that the green values are good, the red values are bad, or maybe the green values are high, and the red values are low. So in addition to all the mathematical calculations you've done, you've now used the colors to give insight to your audience. We've seen the histogram earlier. A histogram is an excellent way to visualize two populations. So as in the earlier example, we wanted to see which of the two groups tended to be older than the other. And now that we've seen where the frequency counts of these people are based on their age, it's very clear that the orange group, or group 2, is the older population. And histograms show you that immediately. My most favorite charts is called the scatter plot. A scatter plot is a chart that shows the relationship between two variables. It's going to be more relevant when you tackle predictive analytics, but in descriptive analytics, it's already useful in showing if there is a relationship or a correlation between two things. So as you can see in this chart, if you look at the blue dots, there's a negative relationship, because as one variable gets bigger, the other variable declines. While if you look at the orange dots, there's a direct relationship, because as the one variable gets higher, so does the other variable. So to summarize, the tools in descriptive analytics. So the methodologies are one thing. What are the types of tools that you can use to execute these methodologies? So generally there are three types of tools. First are spreadsheets. Second are BI, or business intelligence tools. And the third are more customized data visualization tools. A lot of people don't know, but Excel, as spreadsheet, has very, very powerful descriptive analytics tools. Not only can you do data aggregation and summarization using a pivot table, but it has a wide range of charts that you can use to visualize it. In addition to that, Excel also comes complete with a lot of statistical tests which you can immediately use for inference, just like the correlation test and the t-test we discussed earlier. BI, or business intelligence tools, are ways to combine the charts that you can get from Excel with a friendlier point-and-click interface. So some popular BI tools include Tableau, Microsoft Power BI, and QlikView. And these allow the users to just load data and visualize the data immediately without having to create them from scratch using a spreadsheet. More and more BI tools are becoming popular because even non-technical people can visualize data that they need and draw insight immediately, relying on the BI tool's ability to automatically generate the charts. For more technical users, there are also custom data visualization tools. So these are for problems that are too complex for a spreadsheet and something that you can't easily do on a point-and-click interface. So these custom tools are often done using programming languages. So some examples are D3, which is a visualization package built on JavaScript. So the way you develop these is the same as you would develop a website. Or ggplot is an example of a tool that's used with the open source programming language R, which is very popular among statisticians. And matplotlib is a similar package that's used by Python programmers, or programmers who often do a lot of heavy statistical computing. So to summarize, we learned today the various techniques in descriptive analytics and what are the tools that people use to generate these descriptive analytics. Thank you.
Okay, so descriptive analytics, no, is the practice of analyzing historical data to have a better understanding of the business evaluation. So using a variety of historical data and benchmarking, decision makers gain in all-encompassing perspective, of course, of performance and trends on which to base their business plan. Descriptive analytics can assist identifying an organization's strengths and weaknesses. Example of the descriptive analytic metrics include year-over-year price adjustment, month-over-month sales growth, the number of users, and the total revenue per subscriber. Descriptive analytics are currently utilized in tandem with more modern analytics, such as predictive and prescriptive analytics. So, to summarize, descriptive analytics is a crucial element of performance analysis in order for managers to make informed strategic business decisions based on the previous data. Okay, so number 2 is the predictive analysis. Predictive analysis, or predictive analytics rather, refers to the application of a statistical and modeling approaches to forecast future outcomes and performance. Predictive analytics examine current and historical data patterns to determine the likelihood that they will occur. This lets businesses and inventors to modify the resource allocation in order to capitalize on potential future developments. Additionally, predictive analytics can be utilized to increase operational efficiencies and decrease risk. Predictive analytics is a type of technology that produces forecasts about future events that remain unknown. So, it uses a variety of techniques, including artificial intelligence, data mining, machine learning, modeling, and statistics to make this determination. So data mining, for instance, involves analyzing enormous data sets to identify patterns. And text analysis does the same function except for large text chunks. Predictive models are used for all kinds of application, including weather forecast, creating video games, translating voice to text for mobile phone, messaging, and customer service, investment portfolio development. So let's say, for example, if you wanted to develop a game or a video games, it is important for you to understand a predictive analytics. No? All of these applications forecast future data using descriptive statistical models of existing data. In addition, they may help firms manage inventories, devise marketing plans, and predict sales. Additionally, it aids in the survival of businesses, particularly those in highly competitive areas such as healthcare and retail. And this technology can assist investor and financial professional in constructing investment portfolios and mitigating risk. These models identify links, patterns, and structure in the data that can be used to draw conclusions about how alterations to the processes that generate the data would affect the results. Predictive models expand upon descriptive models and analyze historical data to calculate the likelihood of a particular future events given current conditions or a set of anticipated future conditions. As I mentioned earlier, uses of predictive analytics in a variety of industries. Predictive analytics is utilized as a decision-making tool. For forecasting, since forecasting is crucial in manufacturing because it ensures the maximum usage of supply chain resources, critical spokes of the supply chain, such as inventory management in the shop floor, cannot function without precise forecast. Frequently, predictive modeling is used to cleanse and optimize the data utilized for such forecast. So modeling guarantees that the use or guarantees that the system can absorb more data, including information from customer facing processes for a more precise forecast. Credit scoring heavily utilizes predictive analytics because when a consumer or business requests for credit, information about the applicant's credit history and the credit records of the borrowers with similar characteristics are used to predict the risk that the applications will not repay any credit provided. Underwriting. So in underwriting, data and predictive analytics play a crucial role. So based on the present risk pool of similar policyholders, as well as prior occurrences that have resulted in payments, insurance firms evaluate policy applicants to determine the chance of having to pay out for a future claim. Actuaries commonly employ the predictive algorithms that compare attributes to information about former policyholders and claims. For marketing, when developing a new campaign, those in this sector consider how customers have responded to the overall economy. They can utilize these demographic trends to judge whether or not the existing product mix will encourage consumers to make a purchase. When selecting whether to purchase or sell as securities, active traders consider a variety of measures derived from historical events. Moving averages, bands, and breakpoints are utilized to estimate future price changes based on historical data. What is predictive analytics versus machine learning? It is prevalent misunderstanding that predictive analytics and machine learning are identical. Analyzing the past, predictive analytics assists as comprehend possible future occurrences. Predictive analytics is comprised of a number of statistical approaches such as machine learning, predictive modeling, and data mining, and employ statistics, both historical and present, to estimate or forecast future outcomes. In contrast, machine learning is a subfield of computer science that this machine learning refers to the programming of digital computer to behave in a way that, if done by humans or animals, would be described as evolving the process of learning. There are types of predictive analytical models. There are three common techniques used in predictive analytics. I think everybody knows the decision trees, which is already discussed actually in your data structure and algorithms, neural networks, of course, and regression. Decision trees, if you wish to comprehend the causes of person's decision, you may find decision trees useful. This type of model organizes data depending on variables such as price or market capitalization. As the name suggests, it resembles a tree with each separate branches and leaves. No? The branches show the possible options, while each leaf represents a specific selection. Decision trees are the most straightforward models since they are easiest to comprehend and analyze. They are also quite beneficial when you need to make a decisions quickly. How about the regression? This is the most prevalent models in statistical analysis. Use it when you want to determine patterns in huge data sets and when the input have a linear connection. And this approach operates by determining a formula that describe the relationship between all the data sets input. For instance, regression can be used to determine how price and other critical factors influence the performance of an asset. And the third one is the neural networks. As a sort of predictive analytics, neural networks were created by emulating the way the human brain operates. Using artificial intelligence and pattern recognitions, this model can address complex data interaction. Use it when you need to overcome many obstacles, such as when you have too much data on hand, when you lack the formula you need to determine the relationship between the inputs and outputs in your data set, or when you need to make predictions rather than provide explanation. So, how businesses can use predictive analytics? There are a lot of distinct uses for predictive analytics actually, or predictive analysis. Models can assist businesses in advancing their goals and enhancing their operation. Businesses regularly utilize predictive models to enhance customer service and outreach. So this type of statistical analysis can help executive and business owners determine customer behavior. Let's say, for example, a business owner may utilize predictive approaches to identify and target loyal customers who may defect to a competitor. In advertising and marketing, predictive analytics play a crucial role. Using models, businesses can identify which clients are likely to positively respond to marketing in sales activities. Instead of conducting blanket advertising, business managers can save money by focusing on clients who will respond favorably. So, what will be the benefits of predictive analytics? No? Utilizing predictive analysis provides several benefits. As what we mentioned earlier, this form of study can assist in entities in making predictions about outcomes where no other answers are available. Investors, financial expert, and business executive can utilize models to mitigate risk. So for instance, financial expert and business executive can utilize model, or an investor and their advisor can utilize particular models to create a portfolio of investment with minimum risk to the investor by taking into account age, capital, and objectives. Excuse. Utilizing model has a big impact on cost savings. Before a product is released, businesses are able to predict its likelihood of success or failure, or they can reserve funds for productions, enhancement by utilizing predictive approaches prior to the manufacturing process. Due to its apparent injustices, the use of predictive analytics has been questioned and, in some instances, legally limited. This typically incorporates predictive models that result in statistical discrimination against racial or ethnic groups in areas such as credit scoring, mortgage lending, employment, and risk of criminal conduct. This is exemplified by the now illegal practice of redlining in mortgage lending. Regardless of the accuracy of the predictions derived from such analytics, their usage is often frowned upon in data that clearly includes information such as person race is frequently excluded from predictive analytics. Now, how does Netflix use predictive analytics? Meatflex places a significant emphasis on data acquisition. It collects client information based on their viewing history and activity. So it uses data and predictions to generate suggestions depending on the user's preferences. This is the rationale behind the because you watch list on your subscription service. Another is what are the three pillars of data analytics? The three pillars of support data analytics, they are the demands of the entity employing the models, the data and technology utilized to analyze it, and the action and insights that arise from the use of this type of analysis.
Welcome to the lesson. Today we're going to discuss predictive analytics. In this lesson, we will understand what are the techniques in predictive analytics and what are the tools that business analysts can use to perform predictive analytics. Let's define predictive analytics. Predictive analytics concerns itself with modeling relationships between predictors and outcomes. These relationships are tested for accuracy on an initial sample of data. Once you have an acceptable model, predictions can then be generated by feeding the model a new set of data for predictors. So the common approaches in predictive analytics include statistical analysis, training a model, testing a model, outputting a model component or coefficient, and finally outputting predictions. Statistical analysis is the foundation for predictive analytics. So there are many types of statistical methods, such as regression, that attempt to model a relationship between a predictor, or independent variable, and an outcome, or a dependent variable. The types of models and algorithms used depend on what kind of problem are you modeling. So for example, if the outcome you're modeling is a continuous variable, or in layman terms, it's a magnitude, like you're trying to predict the income of a person, then a linear regression is often used. If you're attempting to model a probability or a likelihood, so not necessarily income, but what's the likelihood that this person will earn, let's say, $50,000 a month, that's more of a probability, in which case a logistic regression model is used. And there are other predictive analytics models, like clustering, decision trees, support vector machines. These are all very complex terms, and we're not going to get into too much detail about it in this lesson. It's just enough for you to know that to perform predictive analytics, you must first understand what kind of outcome you're modeling and what are the predictors to that outcome. Outside of statistics, there are also methodologies such as neural networks, which fall closer to machine learning and computer science, and these are also used to do predictive models. So if you want to do a model, the first step is train one. Training a model involves getting a sample data which represents the relationship that you want to model. So a model is trained by applying a statistical model to this training data and then surfacing the relationship. Once the relationship is determined, then the model can be tested for accuracy. So in this example, a regression trend line, which is the orange line, represents the model that was trained on the training data, or the blue line. The shape of the trend line is the relationship that is modeled by this algorithm. Once you've already surfaced a relationship, you have to test it. How do you know if the model is good or bad? How do you know if the model is accurate? So in this example, the trend line generated from a regression is tested for errors using a measure called R-squared, and a graph called the residual graph to see if this was the outcome that's being generated by the model, just how far or how close was it to the historical data that it was trained on. So in this case, we have an R-squared of 98%, which if you are a statistician should be quite high. And let's say you like this model. Then the next step is understanding the relationship. So the model components are the relationships generated from the statistical model. These components will be used later in generating the predictions, but it's often also useful to understand the nature of the relationship itself. So in this example, the model components from the regression line are the beta coefficients generated by the algorithm, while the alpha coefficient is the part of the outcome that the model can't explain. So depending on the type of problem you're solving, the relevance of beta and alpha can change. So with the model components finally determined, you can now start outputting predictions. Predictions are simply generated by substituting new values for the test data. And now that we've seen the orange line as the prediction, the gray line in this example is the possible outcome if we tested more values into the model. So in this case, this model shows us the relationship of time and the trend of this particular value. Let's say this is your company's profit over time. And given this behavior, the prediction is the profit will continue to decline in the next few months, which is not a very good sign if you ask me. So now that we understand generally how predictive analytics is done, let's figure out how do we do this. Sounds like a very, very complex process, and in fact it is. The good news is there are various types of tools and software that business analysts can use to perform predictive analytics. Many people don't realize, but even simple spreadsheets like Microsoft Excel can do simple modeling. So Excel has functions called R-squared, standard error, and residuals, and these are generated using the data analysis function. Excel also has a function called solver that allows the substitution of random variables into a model and constraints. So these are all the building blocks of creating predictive models. For more complex problems that are hard to do on a spreadsheet, and for analysts who don't really want to build them from scratch, there are also tools called workflow interfaces that allow an analyst to easily string together very complex predictive modeling processes using an easy point-and-click and graphical format. So some popular workflow interfaces include K9, RapidMiner. Those are free and open source. And there are also paid and commercial versions like SAS and SPSS. So the idea behind all these interfaces is you already know what kind of processes you want to model. You just want to connect them one after the other and then run the model using a point and click. Of course, predictive modeling can be quite complex, and some problems are really hard to do on a spreadsheet or using a generic workflow interface. So this is when programming comes to the picture. So if the model is too complex or the relationship is just too specific that you can't use a spreadsheet or a workflow interface, then you'll have to go to programming. Modeling can be done using any computer language, but some of the most popular languages include SAS, open source R, Python, and MATLAB. So these are all languages that allow calculations, predictions, derivations of complex algorithms, anything the analyst needs to create these complex calculations. So to summarize, we learned in this lesson the various techniques in predictive analytics, everything from preparing data, creating a model, figuring out the model relationships and outputting predictions, and what are the various tools in predictive analytics, from the simple spreadsheets to workflow interfaces to the more complex programming interfaces. Thanks for joining the lesson.
Okay, again, predictive analytics uses statistics and modeling techniques to determine future performance. So industries and disciplines such as insurance and marketing use predictive techniques to make important decisions. Yes. Predictive models help make weather forecasts, develop video games, translate voice-to-voice or voice-to-text messages, customer service decisions, and develop investment portfolios. People often confuse predictive analytics with machine language, even though the two are different disciplines. Types of predictive models include decision trees, regression, and neural network. So, the most common predictive model is include decision trees, regression, either linear or logistic, a neural network, which is the emerging field of deep learning methods. Next will be the prescriptive analytics. Prescriptive analytics is a type of data analytics that attempts to answer the question, what do we need to do to achieve this? It involves the use of technology to help businesses make better decisions through the analysis of raw data. Prescriptive analytics specifically factors information about possible situations or scenarios, available resources, past performance, and current performance, and suggest a course of action or strategy. It can be used to make decisions of any time horizon, from immediate to long term, and it is the opposite of descriptive analytics, which examine decisions and outcomes after the fact. So, how prescriptive analytics work? Prescriptive analytics tries to answer the question, how do we get to this point? It relies on artificial intelligence techniques such as machine language or learning, the ability of computer program without additional human input, and to understand and advance from the data it acquires, adapting all the while. Machine learning makes it possible to process a tremendous amount of data available today. As new or additional data becomes available, computer programs adjust automatically to make use of it in a process that is much faster and more comprehensive than human capabilities could manage. Prescriptive analytics works with another type of data analytics, predictive analytics, which involves the use of statistics and modeling to determine future performance based on the current and historical data. However, it goes farther because using the predictive analytics estimation of what is likely to happen, it recommends what future course to take. The advantages of prescriptive analytics can cut through the clutter of immediate uncertainty in changing condition. It can help prevent fraud, limit risk, increase efficiency, and meet business goals, and create more loyal customers. When used effectively, it can help organizations make decisions based on highly analyzed facts rather than jump to under-informed conclusions based on instinct. Prescriptive analytics can simulate the probability of various outcomes and show the probability of each, helping organizations to better understand the level of risk and uncertainty they face than they could be relying on averages. Organizations that use it can gain a better understanding on the likelihood of worst-case scenarios and plan accordingly. But, however, prescriptive analytics is not foolproof. It is only effective if organizations know what question to ask and how to react to the answers. As such, it's only effective if its inputs are valid. If the inputs assumptions are invalid, the output results will not be accurate. And this form of data analytics is only suitable for short-term solutions. This means businesses shouldn't use prescriptive analytics to make any long-term ones. That's because it becomes more unreliable if more time is needed. Not all prescriptive analytics providers are made the same. So it's important for businesses to carefully consider the technology and who provides it. Some may provide real concrete results while others make the promise of big data and fail to deliver. Of course, the pros, prevents fraud, reduce risk, and increase efficiency, among other things. It simulates outcomes and shows probably of each. The cons, of course, only as effective as the inputs, not suitable for long-term predictions or solutions, and some big data providers provide results while others don't. Okay, types of data analytics, no? Data analytics is an automated process that uses algorithm. It analyzes raw data and allows the user to make conclusions about that information. Prescriptive analytics isn't the only type of data analytics. There are several others. Of course, we have the descriptive as what we discussed earlier. We have the diagnostic analytics, no? And now predictive analytics, no? So, an example of prescriptive analytics is for airlines. Let's say, for example, suppose you are the chief executive officer of an airline and you want to maximize your company's profits. No? Prescriptive analytics can help you to do this by automatically adjusting ticket prices and availability based on numerous factors, including customer demands, weather, and gasoline prices. When the algorithm identifies that this year's pre-Christmas ticket sales from, let's say, Los Angeles and New York are lagging last year's, let's say, for example, it can automatically lower prices while making sure not to drop them too low in light of this year's higher oil prices. At the same time, when the algorithm evaluates the higher than usual demand for tickets, let's say from St. Louis to Chicago, because of icy road condition, it can raise ticket prices automatically. So, the CEO doesn't have to stare at a computer all day looking at what's happening with ticket sales and market conditions and then instruct workers to log into the system and change the prices manually. Instead, a computer program can do all of this and more, and at a faster pace too. How about the prescriptive analytics in banking? Banking is one of the industries that can benefit from prescriptive analytics the most. That because companies in the sector are always trying to find ways to better serve their customers while ensuring they remain profitable, applying prescriptive analytical tools can help the banking sector, number one, to create models for customer relationship management. Number two, to improve ways to cross-sell and upsell products and services. Number three, recognize weaknesses that may result in losses, no? Such as anti-money laundering. No? And number four, develop key security and regulatory initiative like compliance reporting. How about prescriptive analytics in marketing? Because right now, no, social media is one tools, no, or one way on how we'll be able to market our products, no. So just like banking, data analytics is very critical in the marketing sector. Marketers can use prescriptive analytics to stay ahead of consumer trends. Using past trends and past performance can give internal and external marketing departments a competitive edge. By employing prescriptive analytics, marketers can come up with effective campaigns that target specific customers at a specific time, like say, advertising for a certain demographic during the Super Bowl. No? Corporation can also identify how to engage different customers and how to effective price and discount their products and services. So, what does prescriptive analytics means? Again, prescriptive analytics is a form of data analytics that help businesses make better and more informed decisions. Okay? So it is very important for business because it allows them to look at their past performance and ask themselves. The other forms of data analytics are descriptive, no, kanina, and other, no, and the predictive analytics. Each tries to ask a different questions and may be used by business together or separately to make better, more informed decisions.
Welcome to the lesson. Today we will discuss prescriptive analytics. So in this lesson we will understand what are the various techniques in prescriptive analytics, and learning that what are the various tools that a business analyst can use to perform prescriptive analytics. So first, what is prescriptive analytics? So compared to descriptive and predictive, prescriptive analytics concerns itself with providing recommendations and actions. So you already know the insight, you already know the relationship, you already generated the prediction. The question now is, what should you do? So prescriptive analytics is closer to the ground in terms of what should businesses do, what kind of strategies should you perform. So the methods in prescriptive analytics are also action-oriented. So the most common approaches include simulation modeling and optimization. And these are methodologies that allow analysts to augment and support decision makers in doing their strategies. Simulation modeling is a way of taking inputs into a predictive model that you've already done using predictive analytics and generate many possible outcomes. So you can put many types of inputs into a simulation. They can be fixed, they can be guided, or it can be a random simulation, also known as a Monte Carlo simulation. So the objective of a simulation is to illustrate what are the possible outcomes of an action or decision in order to inform the decision maker on the risks and rewards of that decision. So as an example, a table like this, which is sometimes called a sensitivity analysis, is actually a simulation if you combine two inputs. In this case, what is the price your product is targeting and how much you plan to spend on marketing, and the intersection will be the likely profit or loss of those decisions. Or you can have scenarios, like in this table, various types of business scenarios. You can model a baseline scenario where you expect nothing to change, or an optimistic scenario where everything goes the way you expected, or a pessimistic scenario where everything doesn't go the way you expect. And the reason behind this is you want to be able to provide what is a worst case or a best case scenario for any type of business decision. And that gives decision makers more confidence in quantifying what is the worst possible loss for them to do this strategy. If they're happy with the worst case and the best case, then they can proceed. If not, then back to the drawing boards and figuring out a new type of business strategy. Optimization is actually a subset of simulation. So the idea here is you're also generating outcomes, but you're targeting an ideal objective. So in an optimization model, you're looking not just for possible outcomes, but you're looking for the best possible outcome. And the way the modeling is done is to aid the identification of that best or ideal objective. So if we go back to the pricing chart earlier, we definitely not just want to know what are the possible outcomes at each price target and marketing spend that we've done, but we want to identify which is the best mix. So if we converted the sensitivity chart into a heat map, which is a descriptive methodology, we can see that the green zone is the profitable zone. So that would be the optimal mix of price and spending. Or we can visualize the same data using a 3D area chart. So this actually gives more depth and intuitive dimension to the analysis. You're not just looking at the green zone, you're looking at the highest point in that curved plate. That is your optimal profit target. And that can give the decision maker confidence that, okay, as long as we stay within these boundaries, we're likely to get the optimal outcome. So now that we know what simulation and optimization mean, how do we do it? It seems like a rather complex process. So there are three types of prescriptive analytics tools that a business analyst can use to do these things. The first, again, the simple Excel spreadsheet can do a lot of these calculations already. Assuming your data is big, just small enough to fit on Excel, you can use functions like the what-if analysis and the solver function to create these simulations. And once you've generated the outcomes, Excel's charts become a useful tool in visualizing these optimal outcomes. So in this case, the optimal price objective using that area chart is actually something that Excel can do. For more complex problems, similar to predictive analytics, you will need to go to programming. The advantage of programming languages is you're basically building everything from scratch. And you can code all of the constraints, all of the possible outcomes, all of the relationships into a program. And more importantly, a programming interface allows you to handle much larger sizes of data compared to Excel. So the same programming languages for predictive analytics, such as SAS, R, Python, and MATLAB, are also used for simulation and optimization models. And then lastly, once a simulation or optimization model is generated using a spreadsheet, it is quite a common practice for companies and industries to develop more customized software that actually productionizes all of this. So these software will take whatever models you've already generated using a spreadsheet or your basic programming language and implement them as production-grade systems. So for example, if you're in the oil and gas industry and you want to figure out what is the optimal mix of crude oil and heating oil that will allow you to generate the right type of fuel, and you've already figured that out using programming, you can now put that into the system that manages all your fuel warehousing or all of your fuel production facilities, and now it becomes automated. So commercial vendors such as Lionoso, Profitect, AIMMS, and IBM are often in the business of creating these customized systems for their clients. And the idea of doing this is that once you've already figured out what is the optimal model, you don't want people changing it right and left, as you could do on a spreadsheet or in a program. So to summarize what we learned today, we learned the techniques in prescriptive analytics, primarily simulation and optimization. Simulation is the generation of various outcomes given a predictive model that you've already generated. And optimization is looking for that best or ideal or optimal outcome. And we also learned the various types of tools in prescriptive analytics, whether it's the simple spreadsheet or programming languages or production type systems. Thank you for attending the lesson.
Okay, so the bottom line here is there are many things businesses can do to ensure their success and make better decisions. Data analytics is one tool that they have at their disposal to reach these goals. Prescriptive analytics is a form of data analytics that uses past performance and trends to determine what needs to be done to achieve future goals. So even with the obvious benefits, business leaders should understand that prescriptive analytics has its own drawbacks. No? Knowing where to start and choosing the right company or software to help you reach your goals can certainly help you in the long run. So numerous type of data-intensive businesses and government agencies can benefit from using prescriptive analytics, including those in the financial services and healthcare sectors, where the cost of human error is high. So, okay, so I think that's it for today. So next week, we're going to discuss about the data and database management. Don't forget to watch a video, no, based on the given course syllabi, no, which is already sent to our FB group messenger. So thank you, and I hope you've learned something from our discussion on Module 1 and Module 2. So stay safe, everyone, and God bless.